Hello again. The purpose of this video is to help you with your ALEKS homework over graphing inequalities in two variables. Ignore what the homework number says. As long as the title says graphing inequalities in two variables, this video is to help you with whichever question or questions you need help with. Feel free to fast forward in this video if you need to just get to a further question that is ahead of what we're working on currently. Please make sure that you have your work page. Put your name on that, put your homework number, and also please make sure that you are labeling which question you are working on. So on my work page, after I have it appropriately headed, I would put that this is question number 1, and I would write down my inequality is 3x plus 9y is greater than negative 18. So notice this time my inequality has not one but two variables. So it has x and it has y. So that means that if I were to graph these, rather than just working with one number line, I work with two number lines together, which makes my coordinate plane. All right, so on this question, I don't need to graph. All I need to do is figure out, are these ordered pairs solutions to this inequality? So what I'm going to do is I'm going to substitute in my value, but in this case I have not just one but two values in for my two variables. So I'm going to plug in my 0 in for x. So for my first one I would take 0 and I take my x and replace it with 0. So 3 times 0 and then plus 9. But instead of writing y, I'm replacing it with negative 2. So this is what I'm doing for my question. You would plug in to your own inequality with the appropriate ordered pairs that they gave you. And then evaluate. So 3 times 0 is 0. 9 times negative 2 is negative 18. So 0 minus 18 is negative 18. So is negative 18 greater than negative 18? Is that true or false? And this one would be false. And so because it's false, is it a solution? No, it's not a solution. So then I would come over here and I would mark no. But on my work page, I have this work to justify my answer. Let's go ahead and do one more. So for example, on my next one, I have 7 and 2. So what I'm going to do is still write down the same original inequality. But this time, I'm going to replace x and y with 7 and 2 respectively. So I'm going to have 3, I replace my x with 7, and then plus 9, I replace my y with 2. Is that greater than negative 18? So 3 times 7 is 21. 9 times 2 is positive 18. Is that greater than negative 18? Well, absolutely. 21 plus 18, that's going to give me 39, which is a positive number. A positive number will always be larger than a negative number. So in this case, I get a true statement, which means that here in my chart, I would mark yes, it is a solution, and I would go from there. Please make sure that you check your work as you go. Notice that mine is partial, it's incomplete, so it won't work for me, but you should finish this problem, check your work, and then move on to the next question. The next question is going to start getting into graphing these inequalities. So inequalities, the way we solve them is basically the same way as an equation, pretty much the same thing when it comes to graphing. So remember that good old formula, y equals mx plus b. That's our go-to formula when it comes to graphing a line. Y equals m, which is called your slope, and then b, which is your y-intercept. So always make sure that you're solved for y, and then go through and identify your slope and your y-intercept to graph. So in my case, I have y is greater than or equal to negative 4x minus 1. So what this is telling me, my number in front of x is my slope, which is negative 4 over 1. And my y-intercept, the number after x, my variable, is negative 1. So on my y-axis, my slope tells me how to move. My y-intercept tells me where to start. So on my y-axis, I find negative 1 and I plot a point. My slope tells me to go down 1, 2, 3, 4, and to the right 1. All right, so here is my line. Now, I'm not finished with this question yet. Had this just been an equals, this would be my equation, and I would have graphed my line. But this is telling me y is greater than or equal to negative 4x plus 1. So there's going to be a range of values. All right, so something else that I need to do that I wouldn't have had to do with just an equation is I need to decide, are all of these points on the line a part of the solution or are they not? So if they're a part of the solution, that means you're going to have an or equals to. So because it's an or equals to, that means I'm going to use a solid boundary line. Had it been the less than or the greater than symbol only, that means I would have used a dashed line. So notice that my line automatically comes up as solid. If you need to switch it to dashed, you're going to click on dashed and then you can click on your line. All right, I don't want that. All right, so I'm going to convert it back. I'm going to convert it back to a solid line. The other thing is, we don't just have ordered pairs that are solutions to this inequality that are on the line, but we also have either this half of the coordinate plane or this half of the coordinate plane that will be solutions as well. So the other part to this problem that I need to do is figure out where am I going to shade. And so to do that, I'm going to choose what's called a test point. And for that, I'm going to pick any point that is not on my line, any point that you want that is not on your line, and plug it in, just like we did on question number 1, plug it into the inequality to see if you get a true statement or a false statement. All right, so for example, my hand's kind of pointing down here, so I'm going to go ahead and use this point right here. This point is at -7, -9. -7, -9. You don't have to choose that point. You get to choose any point that you want that is not on this boundary line. So here I have -7, -9, and I'm going to plug those into this inequality. So I'm going to replace my y with -9 is greater than or equal to -4, and then instead of writing x, I'm going to replace that with -7 and then -1. So this gives me -9 is greater than or equal to -4 times -7 is +28, and then -1. This gives me -9 is greater than or equal to, and then 28 minus 1 is 27. So this is saying that -9 is greater than 27. A negative is greater than a positive. That is false. That is not true. -9 or -7, -9 should not be a solution. So that means that I need to, okay, my arrow was already pointing down here. I need to not shade on this side. Rather, what I need to do is click on this shade button, and I need to shade on the opposite side of the line. Since this is where -7, -9 was located, and it was false, that means I need to go to the other side of my boundary line and shade on that side. And then, as always with homework, please check to make sure that you're right. The point of homework is to practice. Check to see if you're right before you move on to the next question. Question number 3, just like question number 2, I am given an inequality. First thing I'm going to do is graph that boundary line. And before I even get to work with this, I'm going to note that this says less than or equal to, which means, once again, I'm going to use a solid line. Had it just been less than or had it just been greater than, I would have a dashed line. But since it says or equal to, that means I'm going to use a solid line. The next thing that I would do, so on my work page, I should be doing this. This is question number 3. I'm identifying that this would be a solid boundary line. The next thing that I should do is identify my slope. The number in front of my x is a -5. I like to write my slope as a fraction, so then it tells me how much to go up or down, and then also don't forget to always go over. And then my y-intercept, the number after that x, is -2. So what I would start with would be to get my line tool. I can either make that solid or I can make that dashed, depending on what I need it. I already identified that this needs to be solid. And then on my y-axis, I would plot a point at -2. And then my slope tells me how to move from there. So negative means I'm going down. So I go down 1, 2, 3, 4, 5. And then I always move to the right. So in my case, I'm going to go over to the right 1. I need a solid line, which is what I have. All right, now I need to shade still. I'm either going to shade on one side of this line, either on the left side or on the right-hand side. To figure out where I'm going to shade, I'm going to pick a test point. Pick whichever point on that coordinate plane that you want, as long as it is not on the boundary line. So pick whatever ordered pair that you want. I think for this one, I don't care. It really doesn't matter. Let me go ahead and choose -1, -1. All right, so -1, -1. That's this point right here. All right, so here's my x, here's my y. My inequality is y is less than or equal to -5x minus 2. So I'm going to replace y with -1, is less than or equal to negative 5. Now I replace x also with negative 1, and then I have minus 2. So negative 1 is less than or equal to, I can use Desmos over here. Negative 5 times negative 1 is positive 5, and then minus 2. So negative 1 is less than or equal to 5 minus 2 is 3. All right, so this inequality is opening up towards the 3, which is saying 3 is larger. So is 3 larger than negative 1? Is that true or false? And in this case, it is true. So because I chose a point that is not on my line, that was true, then what I'm going to do is I'm going to get my shading tool and I'm going to click on where that ordered pair was. And it's going to say anything that's on that side of that boundary line would be true, which makes it a solution. So all of these, any points in this shaded region, would be solutions to this inequality. And then as always, I would check to make sure I'm right before I move on. All right, question number 4 has a little bit more work to do for it, not much. But when it comes to graphing this inequality, x plus 4y is greater than 12, or just greater than 12, I need to get this solved for y. All right, so where's my y? I need to put this in the form y equals mx plus b. So that means my x term needs to go to the opposite side. Since I'm doing the opposite, it's a positive x, so the opposite of positive x would be minus x on both sides. So x minus x cancels out. This leaves me with positive 4y is greater than, and then I'm going to bump the 12 over and slide in my negative x. That 12 is positive, so I'd put plus 12. Because notice I'm just trying to put this in the form y equals something x plus b. So in this case, I have y and then something x and then my number without that variable. All right, but I just want y, and this is 4 times y. So the opposite of times is divide, so I'm going to divide everything by 4. Since it is dividing by a positive, it means I keep the same inequality symbol. Had I been dividing by a negative, I would have had to switch that around. 4 divided by 4 cancels, leaving me with y is greater than. I have negative x over 4, which would be the number negative 1 over 4x. And then positive 12 divided by 4 is positive 3. So my slope, m, is negative 1 over 4, and my y-intercept, my b, is positive 3. Something else before I begin is this inequality symbol was just a greater than symbol, which means that I'm going to use a dashed boundary line. These points that I'm about to plot are not a part of my solution. All right, so I'm going to grab my line tool and I'm going to plot a point on my y-axis at positive 3. My slope tells me how to move, and that means since it's negative, I'm going to go down 1 and then to the right 1, 2, 3, 4, and I plot my point. This one needs to be dashed, so I'm going to click on this tool right here, which is saying go from solid to dashed or dashed to solid, and then I'm going to click on my line, and now I've made it dashed. All right, so right now I haven't graphed any solutions. I don't have anything really, okay, because the dashed lines means that those points are not a part of my solution. So where are the solutions? All right, so these solutions are either going to be above this line that I just drew or below this line that I just drew. How do I know where they are? Well, that is where the test point comes into play. So that's, once again, a test point. Pick any point that is not on the boundary line. So 0, 0, I think is what I'm going to go with for this one. I could have gone this point again where my pointer was pointing to, but it does not matter as long as I don't pick a point that's on my line. So I'm going to go for 0, 0, so my x and my y. Plug into the original inequality. So instead of writing x plus 4y is greater than 12, I'm going to replace x with 0. Plus 4, instead of writing y, I'm going to replace y with 0 is greater than 12. So 4 times 0 is 0, plus 0 is 0. Is 0 greater than 12 true, or is that false? Well, 0 is not bigger than 12, so that means that this is going to be false. All right, so see where I plotted my point here? What that means is I need to click my shading tool. Instead of clicking on that point where it is, I need to go to my line and I need to go to the opposite side and click. And that means that all of my solutions lie above my line. And since it's homework, I can check it to make sure that it's right before I move on to the next question. Question number 5 is once again going to be graph the inequality, but my inequality is not solved for y. So step number 1 is take the inequality and solve for y. All right, so I need to put it in the form y equals mx plus b. So first thing is move the x term to the other side. I have a positive 5x, so the opposite of that would be a minus 5x on both sides. 5x minus 5x cancels out, gets me to 0. So then I'm left with positive 2y is greater than, I'm going to slide my positive 2 over and put my x term first. So this would be a minus 5x. And then this is a positive 2, so I'll put plus 2. Last but not least, y is being multiplied, so I'm going to divide. I'm going to divide everything by positive 2, and since I'm dividing by a positive, my inequality symbol stays the same, and I'm left with y is greater than negative 5 over 2x, and then 2 divided by 2 is positive 1. So this is telling me my slope m is negative 5 over 2, and my b, my y-intercept, is positive 1. All right, so I'm going to come over here to graph, but before I graph, I'm going to figure out this line that I'm going to graph, is it going to be solid or is it going to be dashed? And it is going to be dashed because this is a greater than symbol. It doesn't have the or equal to, which means that these points that I'm about ready to plot are not a part of the solution. So my y-intercept is positive 1, so on the y-axis I plot a point at 1, and then the slope tells me how to move, which is telling me to go down, since it's negative, down 1, 2, 3, 4, 5, and to the right, 1, 2. So I plot my second point based on how I move, and then I need to get this tool which says convert my solid line to a dashed line. So once again, I don't have any solutions right now. I don't have anything on my graph that's telling me where my solutions lie. This is telling me that this is splitting my graph, but are my solutions over here to the left of it, or are they over here to the right of it? So to determine where those solutions are going to be, I need to do a test point. Pick any point that is not on the line. All right, so any point that's not on the line, my pointer is pointing to 6, negative 8. So I'm going to go ahead and use 6, negative 8, my x followed by my y. And I'm going to plug it into the original inequality. So this is going to be 5 times x, but I'm choosing x to be 6. So 5 times 6, and then plus 2 times y, which I chose y to be negative 8, is greater than 2. So 5 times 6 for me would give me 30. 2 times negative 8 is negative 16. Is that greater than 2? So 30 minus 16 is 14, and 14 is greater than 2, which is true, which means that here where my pointer is pointing to, that's the ordered pair that I chose, I'm going to get my shading tool and I'm going to click where 6, negative 8 is located. And that's telling me that this side of my graph is going to be solutions. And then I can check my work and make sure that I'm right before that I move on. Question number 6, notice that this one's a little bit different than the last one because it's just y is less than 2. All right, so this is just one variable. Okay, so this means that it's only guaranteed to go through one of my number lines. Since this is telling me what my y value is, it's telling me whether it's going to go through my y-axis. So this is telling me that I'm only guaranteed to go through the y-axis, and I go through the y-axis at 2. All right, so what I'm going to do is I'm going to, well, I guess before I grab my tool, I need to decide if it's going to be a solid line or a dashed line. And since this is just a less than symbol, not or equal to, it means I'm going to be using a dashed line. So I'm going to go ahead and grab my line tool, find my y-axis, and I'm going to plot a point at 2. Okay, how can I maneuver my arrow? How can I maneuver my pointer so then I can make it so I only have a line that goes through the y-axis? Well, I'm just going to move over. And this is showing that I'm going to have this line that only goes through the y-axis. It doesn't go through the x-axis at all because it's only going through at y is 2. Since it's a dashed line, or it's supposed to be a dashed line, I'll click on my tool and I'll click on my line and I can make it dashed. And now I need to figure out where am I going to shade. So where am I going to shade calls for a test point. So pick a point that's not on your line. I'm going to go ahead and go with 0, 0. So here's my x, here's my y. My inequality is y is less than 2. So I only have a y value to plug in. So I'm going to replace y with 0. Is 0 less than 2 true or false? That is true. So I would be using my tool here to shade. I'd find where 0, 0 is, and then I click on 0, 0, and it automatically shades for me where all of those solutions will be. And then I'll check my work before I move on to the last question. My last question is very similar to question number 6, but instead of just working with the variable y, now I only have the variable x. All right, so I have x is greater than -3, which only tells me that it goes through the x-axis. It's only guaranteed to go through the x-axis at -3. Also, I need to note that it's a greater than symbol only, which means that my solution, my line, is not included in the solution, so it needs to be dashed. So I'm going to get my line tool. I'm going to find my x-axis, and then I'm going to find -3 on the x-axis, and I'm going to plot a point. And then how am I going to make it so this line only goes through the x-axis? Well, I'm going to go up and down. All right, so now what I need to do is convert that line to be dashed, and then I'm going to need to figure out which side am I going to shade. So pick an ordered pair that is not on your line. So right now this is pointing at 10, -2, so why not? I'll use that ordered pair. So here's my x, here's my y. My inequality is x is greater than -3. So that means I can only plug in x. X is 10. There isn't a spot for where y is to go. So that means I only plug in 10 for x is greater than -3. Is that true or false? Well, once again, that is true. So I'm going to click on my shading tool, and I'm going to click on top of the test pair that I used, and then it automatically graphs or shades where all of those solutions would be. And I'll check my answer and make sure that I'm right, and then submit my assignment, and then I will be finished with graphing inequalities in 2 variables.